Concept 2, factoring by greatest common factor and recognizing patterns. Alright, so if you remember from our last lesson in our last chapter, we have some special products of binomials. We have the perfect square trinomials, both the positive and the negative ones. And then we have the difference of two squares. Alright, and the idea behind this lesson is even when we have a trinomial like this one that is not a perfect square trinomial or the difference of two squares, it could be that when we pull out the greatest common factor, that's what we're left with. Okay? And it's mostly just a reminder to check to make sure that there isn't a perfect square trinomial or a difference of two squares that we can use a formula to figure out quickly. So if I'm looking for my greatest common factor, let's see, I got 5, 25, I got 10, 20, 30, 3, I got 3 and 4. Looks like 3 is going to be my greatest common factor, and I've got at least one x on all my terms, so 3x is going to be my greatest common factor. 3x times 4x squared is 12x cubed. 3x times 20x is 60x squared, and 3x times 25 is 75x. Okay? Alright, and now I can see that 4 is a perfect square, 25 is a perfect square, so my root for this would be 2, my root for this would be 5, and 2 times 5 is going to be 20, so this does look like a perfect square, and I should have 3x times 2x plus 5 squared. Okay? And you can notice I could have done it normally by factoring. This just saves me some time. Alright, so this one we've got just two terms. So immediately when you see one with two terms, you should be thinking about the difference between two squares. Alright, in this case I've got 3x to the 5th minus 12x third. That's another thing you'll need to have if it's a difference of two squares, is it needs to be a difference, it needs to have a subtraction. Pull out my common factor of 3x to the third. So 3x to the third is going to leave me with x squared. And then I'm going to have minus 4. Okay, x squared minus 4. 4 is a perfect square. X squared is a perfect square. Alright, so if this is the difference of two squares, remember that's going to be 3x cubed, my outside term, times x plus 4, x plus 2 times x minus 2. Okay, again, just a little time saver. Alright. Okay. This can also happen with extra variables. Okay. In this case, I have 8pq to the second plus 8pq plus 2p. Right. My greatest common factor is going to be 2p. So I have 2p times 4q to the second plus 4q plus 1. Alright. 4q to the second is a perfect square. 1 is a perfect square. This would be 2q, and this would be 1. 2q times 1 times 2 gets me 4q. So this does look like a perfect square trinomial, and I can use the formula to get 2q plus 1 squared. That's it.